Hey guys, got some interesting phenomenon to share with you. According to the present invention, I employ an electrolyte, or in general, a conducting liquid in lieu of a solid, as the material for the armatures of the condenser. A jar within a jar. Electrodes are a 6-inch long by 4-inch wide piece of aluminum flashing, and the center terminal is about a foot square piece of thick aluminum foil that I just folded up. Borax, Epsom salts. Yeah, hold on. Get over there. Borax, Epsom salts, and water, and a thin layer of oils of mineral on top for insulating purposes. This is our ground rod hooked up here to the bottom of the condenser, or the outer terminal, and all I have is my AC voltmeter in parallel with the condenser. There's nothing else hooked to the other terminal. So as you see, we have this almost a volt AC accumulating. I'll show you some other things in a second here. Very sensitive to electrostatic influence. Put my hand on the table, we can see it draining slightly over here. Sometimes it gets higher, sometimes it drains more. So I got my carbon rod here out of a battery that I was going to also try. So I'm going to pull this out and show you just some different stages of, let me put this away, different stages of output from it. First I will take this out and show you as the water drains out, the voltage is starting to increase even more by just being up in the air like that. It's maybe starting to think it's got to be RF based, but all the leads have to be off the table. If any of the bare metal touches the table, it seems to deplete the energy. So I'm going to hook it to the carbon rod. This came out of a 6-volt lantern battery, one of these deals. So we'll put it in there and watch the voltage. Let me get this out real quick. We're sitting at around 1.3 volts right now, just in the air, and this is AC, by the way. So putting an electrode in there actually makes it go down. Not quite sure why that case is, so I'm seeing something different than the actual condenser charging, perhaps. Maybe just acting like a better antenna. So one thing I found was by laying that on the table, then when I actually touch this to the table, the voltage jumps way up, 4.2 volts AC. Look, that's just sitting right there on the table. I'll just take that off and show you. Now I'm going to take and just touch the lead itself to the table. You can see the voltage starts to climb, depending on where I'm at. Put it over here. It's a little different. So I hook it to this metal cap here. Gives it a little more surface area. 3 volts. If I touch it, it goes up a little higher, using myself as an antenna. Touching the table still decreases it. 0.2 volts or so. So then I was playing around with this thing again, because surface area seems to be related. Obviously it wasn't doing crap in there. I hold it up in the air and get some slight fluctuations up and down, depending on the altitude of the thing. But the weirdest thing was when I laid it on the table like that, or closer to the meter, closer to the jar, I mean. We broke 5 volts earlier. If I get it real close, I'm just moving it around. So as soon as it makes contact with that table, this voltage starts accumulating. This AC voltage starts accumulating. Very weird. Let me turn the scope on here. I'll show you in a second. Rectified it through that overnight and saw about, that was with the terminal in there before I even discovered this other issue. I saw about 7 volts DC in that overnight, about 8 hours later. So this is pretty interesting. Hold on one second, let me hook the scope up. Okay, here's with the scope on. I'm reading off of that aluminum piece of foil sitting on the table here. Every once in a while, it's pretty flat. I mean, there's a little bit of a squiggle here. This is all the way up on the volt scale, or all the way down, excuse me, on the volt scale, 0.01. And every once in a while I can see a tiny spike happen, and it is not regularly occurring, obviously. You might get one. So I don't know, there seems to be a little bit of a disturbance there, so that might be the source of the fluctuation. But as you can see, the voltmeter, or the oscilloscope wasn't really adding, I moved it, adding any to the accumulation. So let's rectify this and see what happens. Hold on. Okay, we're back. Wasn't very long for you, was it? So I've hooked up the rectifier. It's coming off of this terminal. This thing just laying here, and the other side of the condenser. Nothing in the ground rod's hooked to this side as well, the outer plate. Rectified, coming out, going to the capacitor, and I have to just tap it on here because the voltmeter is a load and it is draining it slowly. But look what we got up to already, 7 volts. Now let me see if I can short it. Okay, so we're at 0. Now watch. Comes up there pretty quick, doesn't it? What in the world? This is DC accumulation just from the table. I mean, I don't have anything else plugged in or turned on. All my equipment's turned off here, so that, like, RF feedback from this 60 hertz, it's unlikely. I turn off the overhead lights, it's the same effect. This will go up way faster if I take the load off, but as I can show you now, let me touch it again. See, 4.5, 4.8. It'll hold at 5 or above, even with the meter hooked up. Now this is DC now because we're rectified. Let's see, DC. It's quite interesting. Let me see if I can light some LEDs with this. See, I'll make another video for that though. Very interesting.